to a short tutorial of Lecture 2 about RAMS analysis. RAMS analysis stands for reliability, availability, maintainability, and supportability, and these are the 4 dimensions in which we traditionally evaluate the maintenance processes. So, consider that you have a use case that was provided by an airline, and they want you to calculate measures or metrics or indicators that allows them to understand better their maintenance processes, their limitations, and how to improve their performance in the future. So they give you data, and they ask you to calculate reliability indicators to start off. And one of the most important reliability indicators that you can calculate is the mean time between failures. This is calculated by dividing the uptime over the number of failures. And the higher the mean time between failures, the better. The lower, it means that you're failing more often than you should be. Start by importing libraries, and in this case I'm just going to use NumPy and pandas. And we are going to read our data frame. So we are going to read using pandas. Our SCV. Let's put this in caps. Okay, we have it here. Okay, and then we're going to print the first 5 rows of the data frame. Let's run. Okay, so we see that we have the equipment, the date of the repair, and all the other columns are here. Okay, if we want to remember the names of the columns, we can always say this. So we know that we have equipment ID, date of repair, time of repair, and so on. Okay, and what we want to calculate is the total uptime to start. And for that, we need to sum the partial uptimes. But since we don't have the uptime, but only the total maintenance time, what we can do is we can calculate the downtime. And that will be df plus copy, paste, okay? And then, because it's in minutes, we can calculate the total uptime as 24 versus 365, because we know that's the total time, because you know the date was taken during 1 year of 365 days, and then we take out the total downtime, and to calculate the mean time between failures, we do total uptime divided by the length, the number of failures, which equals the length of our data frame, so the number of rows. In this case we do number of failures, and let's see what happens. And then of course we have to print mean time between failures, total uptime, sorry, mean time between failures divided by 60 plus 24, so that we end up not with minutes but with days. Okay, and then we have 2587 MTBF. Another important aspect of RAMS analysis is the aspect of maintainability. Maintainability has to do with the time that you spend doing the repair itself. And we are going to talk about three important metrics for maintainability: the mean downtime, the mean time to repair, and the mean repair costs. Total downtime. It's easy to calculate the mean downtime as the total downtime divided by the number of failures. And in this case we have print downtime equals downtime. It's already in minutes, so we can check, and it gives 278 minutes. Okay, that's good. Now we can calculate the next, which is the mean time to repair. And how we calculate this, it's a little bit trickier. You have to calculate the total repair time as the number, as the total maintenance time minus the support time, because you have to take out the support time from the total maintenance time, and only then you can calculate the mean time to repair as the total repair time divided by the number of failures, and then you can say mean time repair, sorry, here should be T equals the mean time to repair. Okay, and now we play and we get the mean time to repair here. Okay, the final is the mean cost, which is easier to calculate. It's mean repair costs equals the total cost, which is numpy sum there on the column costs divided by the number of failures. Okay, and then we can print MCR. MRC, sorry. Now we run and we have the mean costs per failure. Another dimension that is important is the supportability, that has to do with the time that you spend preparing your repair after you know that you have to do a repair. That's the time to support, and the mean time to support is one indicator that is useful to know in average how long it takes for you to support a maintenance task. The mean time to support is the total support time over the number of failures, so quite easy to memorize. Calculate the mean time to support. Okay, total support time equals NP sum df support time in minutes. Okay, and then you calculate the mean time to support equals the total support time over the number of failures. Okay, and now we can run and we get the total support time, which is smaller than the time to actually repair if you check the two numbers, but quite close. So something might not be perfectly well with your maintenance operations. Finally, we have the dimension of availability, which is very important because it gives a summary of all the other dimensions. So it's basically the uptime over the total time. So it's how much time the system is available. Availability. And interestingly, we have these two formulas that leads to the same result. Total downtime. Okay. And let's check if we calculate the availability by the formula of the mean time between failures and so on, equals this calculation here. And yes, it's exactly the same. So the availability is actually quite high.